Hello, welcome to Enlightning. Thanks so much for being here today. Today, Victor is going to teach me and you about service mesh and about Kuma in particular. We're doing a series on service mesh. We did Linkerd last week, and we'll do Istio next week, and Cilium too in November. So, welcome so much, Victor. So glad to have you.
I'm glad to be here. It's great that you providing me with this platform to teach people with the beauty in some internals of Kuma Service Mesh.
I'm so excited. Tell us about
I'm, I'm
you
I'm
and
excited as well. Yeah.
I like that about us. I can tell. I want to hear about you, but I can infer already that you're a professional streamer just based on your super professional streamer looking background. But tell us about
Yeah.
you. Yeah.
Yes. Thank you so much. Yes. I'm a principal developer advocate at Kong, and if you have a developer advocate in your title, you must have a streaming setup because that's what we do for the last 2-3 years. The things
There needs
change
to
in
be some purple light in your background, or clearly you don't know what you're talking about, right?
yes. The things changed significantly for us for our doing the duties. In the past, we were like travel and speaking at the conferences and spending a
Yeah.
lot of time in hotels. Now we still at home and we are streaming from our places, and
It's
everything should look good and professional and in style of modern YouTube and things like that.
Yeah. When I meet someone new and they're like, "What do you do for a living?" I like to be like, "Oh, I'm a 44-year-old professional streamer."
Yeah. That's how we do it. I always struggle to explain. And when the people
Yeah.
people, especially like in school, kind of like when you are over a certain age, you're not making new friends anymore. You're making friends with parents of your kid friends,
Okay.
and it's normal people. The people that go to office and doing some office stuff, and they're asking like, "What do you
Uh-huh.
do?" And I was like, let's call it education. I work in IT and I do education.
Okay, I like that. Yeah.
Yeah.
Yeah,
It's not
especially
like
like with the light board. Yeah. I feel it.
it's not like I'm ashamed of the things that I do, but it's much easier to explain into words that, you know, what's the difference between evangelism and advocacy, and without going into this kind of like a um in the deeps of explaining this. Yeah, I do consultancy, I do education, and I'm in IT. So that's something
Love
that
it.
you need to know.
How to say it in a snappy way. I want to
Exactly.
say,
Yes.
yeah, hi to Srinatha. Hello. Thank you so much for being here, friend. So glad to have you. Um, what, so before I actually met you already, we've streamed together during a cloud native live show. But before that, I'd heard of you, but I thought you were a Kafka guy. Like I knew you wrote a book called Kafka in Action. I'm gonna link to it.
Yeah,
Oh,
that's
Fuel
true.
Snobbles here. Hello, Fuel
Yeah.
Snobble. Yeah. So how did you?
I
So now you're a Kong guy or a service mesh guy or a Kuma guy. Tell me how you got from one to the other, please.
yeah, that's actually very interesting conversation. Essentially I came from consultancy background, and I spent
Uh huh.
I guess over maybe up to 8 years in a data world, distributed systems
Mm-hmm.
world, distributed databases world. I started in the
Okay.
world of distributed in-memory databases, data grids. Moved to world of streaming data, and start doing a lot of work around the Kafka and the technologies around the data streaming. And like 2.5 years back, I switched to more on kind of like an API and data application layer and the software defined networks and Kubernetes world. It's definitely changed for me. Emergence of the Kubernetes as a platform for deploying the
Mm-hmm.
system changed the way how I approach the things what I do. One of the things that
Mm-hmm.
I start doing is explaining people how to run stateful workloads like Kafka, like databases inside the Kubernetes world, what kind of things to pay attention. Some of the things are ready to be implemented, so you can just simply you run some of the things. Some of the things needs to be tweaked,
Uh
specifically in the
huh.
world, Kafka is notoriously difficult if you deploy this in a certain. Kafka was not designed to be cloud native to the very beginning when
Yeah.
it.
Uh-huh.
It was designed to be running on the bigger, the VMs and the bare metal machines. And over the years, many contributors they make this Kafka more cloud native friendly, and now we have different operators that allow you to do this. There's open source in CNCF called StreamZ. There's a proprietary that comes from the different vendors, and so that time I started like looking at the Kubernetes world and what things are available, and it fascinated me a lot with the networking capabilities, what the things can be done, and um, what I can tell people and how I can show what's the best practices. So right now I do a lot of things with Kubernetes. Conk is a cloud API connectivity company,
So
and we're doing the things with APIs, REST API, gRPC, and Service Mesh. It's kind of like people like to talk about this as kind of
yeah.
another side of the coin when we're talking about APIs.
I
Um,
I I have some things. Well, I want to say hi to some friends, and then I have some things to say and questions to ask. But Fuel Snobble's here. Hello, Fuel Snobble. Always fun to have Fuel Snobble. Gorbash is here, which is great. Says hello from India. Cormaj is my great question asker. Code with Sean is here. Hello, Code with Sean. And Fuel Snubble, I've never had any problems with Kafka clusters in cloud.
yeah, seriously though, like
Perfect.
you know,
Yeah, easy peasy. So it sounds like what's interesting to me is it sounds like you were naturally touching technologies like Kafka for events driven stuff and like just data stuff that are both big challenges, events and data, once you move into a cloud native distributed architecture. And so you've been right in the middle of trying to figure that out, it sounds like.
yeah, a lot of Kubernetes was very eye opener for application deployment. And many people just like wanted to all of a sudden they wanted to run all workloads in Kubernetes, and
Uh-huh.
people saying, okay, so like I'm running my apps there, like what could go wrong, like what could go wrong if I would just decide to deploy heavily distributed system on top of another distributed system that depends on another distributed system. If we're running Kubernetes, it's distributed system across like a multiple machines, underlying infrastructure. You're running Kafka, that is distributed system that will be relying on Zookeeper for the the some time in the past. Zookeeper was the integral part of this deployment. Plus, you need to think about how you can think about the storage and how the storage will be distributed. So there was a lot of things to talk about this. What could go wrong with the storage, what kind of type of storages you need to use, what's the network capabilities, what needs to be taken care of. And during the time when I was talking about those things, I also learned a lot of through the customer deployments. I spent some time in professional services, so I was doing actual deployments in integration for customers, just like happen to go the customer side and spend I don't know, like the week trying to install the things in their infrastructure. And with this, I learned a lot of there's a famous joke about like CNCF when you're looking and trying to explain to people CNCF landscape, and you can always
Yeah.
have a meme from It Always Sunny in Philadelphia, where the Charlie Day would, the character will explaining who's the Pepe Silva and like how to deliver mail to them. So, yeah,
Fuel Snubble, I hope you're still here. Fuel Snubble said if someone says the word zookeeper, I run to the woods. And then you said it, so
not
hopefully we
anymore.
didn't
Not
lose them.
anymore. Now, not anymore. Now we got rid of this, and the Kafka runs its own metadata service these days, and you can be happy.
There you
Not
go.
not not everyone is happy as always, but majority of the people happy with not having zookeepers right now.
So last time I learned about distributed clusters, I realized there's another circle to hell.
Absolutely. Yeah, that's absolutely
Feels
true.
novel. Just a ray of sunshine in our stream every week. Love you, feels novel. Okay, so let's give this conversation some context. I think there are two things I think I want to know context wise before we dig into Kuma specifically. One is I'd like to understand kind of like what problem, I guess, first, maybe a general definition of service mesh, because we were saying we're doing service mesh. So I'd like to make sure we're level set on that. And then, like, what was the scene like when Kuma was created? Like, why did Kuma need to get made? Why was the current technology already in the landscape not enough? Those are my two questions.
Uh, so when we're talking about service mesh, I think service mesh is like remember the story when a few like scholars or old people, they kind of like the thinkers, scholars, philosophers, they met the elephant, and
Mm-hmm.
because they were old, their vision was slightly impaired, so they would not be able
Mm-hmm.
to see everything clearly. However, they were able to touch the elephant, and they different people were touching this in different parts, and they will have a different idea what exactly they're touching because of the
Uh-huh.
the rough skin. What is it? Is it snake, like because of the nose, like is it snake,
Uh-huh.
some weird thing. So the skin is rough, something is big. What is that? So same thing is that
Okay.
they give a different definition of this animal, and the same thing with the depends of who you're talking about. Service mesh,
Uh-huh.
if you're talking the people on infrastructure they deploy and saying, oh, that's the thing that you deploy to get observability, or
Uh-huh.
you're talking about the thing that some people who already deep into service mesh say, they might say, oh, you don't need this because you're running only two microservices, and it's just like overcomplicate things. um
Mm-hmm.
I think in general, like very kind of like the Oxford Dictionary type of definition of a source mesh,
Yes.
that would be a concept that allows you to have a some sort of centralized control plane over over your application. So you will be able to declaratively define the traffics and declaratively define how your application are communicating. um, Essentially service mesh contains like two parts, and it's going to be one to many relationship. There would be a control plane that would be responsible for holding configuration, and there will be
Mm-hmm.
data planes that will be deployed with your application, and
Mm-hmm.
provide the actual communication between your application. So
So, yeah.
no, go ahead.
A service mesh is a technology that gives you a centralized control plane. You said over your application, and I wanted to double check. Is
Over
that,
your application communication, I would say.
okay, over application communication
Yeah.
to
So like
watch. Yeah.
let's imagine like before we going into microservice, people also like to talk about microservices when they talk about service mesh, but it's not necessarily requirement. So let's talk about this any distributed network application. So we have
Uh-huh.
a monolithic application, some Java EE application server. If if you the old enough, you remember the times, and when you deploy application on your application server, you have certain things out of the box. For example, you
Uh-huh.
want to connect to database, and application server already have a connection pool configured in some system administrator configured this to you.
Mm-hmm.
So when you deploy application into application server, um, you're getting first thing is a service discovery, because you're just saying, okay, so I know the name
Mm-hmm.
GNDI name. It's a Java thing, but it's not a real one. You know the name, and application server will inject you actual address of this database server.
Mm-hmm.
The next thing is that you might want to have some sort of um, ability to have reliable connectivity, because you don't want to open connection database every time you need to run the query, and you don't want to spend the time to manage this. So you will have a connection pool to this system, and the application server provides you with this. So your application, you program against this type of API. So service
Mm-hmm.
discovery, connection pool, reliability, retries. Um, Also, your application might not need to store the passwords to the system because your infrastructure will have a connection pool. As a developer, I don't really care about security. I won't want to care because as
Mm-hmm.
operations people need to think about this. Is my connection to my database secure? Um, so how I can do this? And usually operations people will go there, they generate certificates, that they put the certificate. If it's some sort of like a mutual TLS, they will have a certificate that they will sign all the certificate, and they will have like a mutual communication between um, your application and your database. So next thing is that you also need to have your application talks to database, but your application has some sort of UI. You need to, or like API, the REST endpoint, or whatever. You need to expose this to outside world. So for
Mm.
this, you need to put the load balancer in front, and you don't want to expose this with the to outside world without any type of security. You need to put some sort of like HTTPS certificates on top of this. So you also need to implement all these things.
So
And yeah.
I thought that exposing it to the outside world was a job for Ingress type technologies, not a job for service mesh.
Exactly. But we,
Yeah.
we will talk about this, the table discussion, because this is a very,
Okay.
very interesting question to talk about.
Okay.
Um,
Should I
I'm
write it
I'm kind of
down?
like a
Expose your application to.
yes, of course. It
Okay.
is actually it's going to be a big thing, hopefully this year at the KubeCon, because there would be a bunch of announcements, and there's a bunch of um, um, kind of like a specification and sense, a lot of work that is happening in some of the special interest groups. Specifically, I'm talking about this Gamma project, which is a gateway API
Uh,
for merge technology. So um,
okay.
we're going to talk about this. So think
Okay.
about all the things
I
that
want
you
to.
just write down.
Uh-huh.
Think about
Yes.
this: service discoverability, connection
Uh-huh.
pooling,
Uh-huh.
reliability, centralized configuration, exposing the application to outside world. So all these
What was
things.
the third thing you said? Did you say reliability?
Yeah, so like you have a connection pooling. That's something that you can put. The connection between application is reliable. Retries,
Oh,
circuit
okay.
breakers, all these kind of things.
What's connection pooling?
So in the world of the good old days,
Uh-huh.
when we were not web scale, um, people were doing this. You have a request that comes into your application,
Uh-huh.
and if you need to fetch something from database for one request, you go into database, you open connection database, you do a SQL query, and you get the result back. And when you're running this with the hundreds of connections, you
Uh-huh.
immediately depleting this like a network stack that talks to your database. So you need to some sort of system that will be managing those connections.
Okay.
Maybe you don't have to close connection all the time. You can keep some of the connection open whenever you need to call it, and after that you will take the connection out of the pool, and you run your query and you send back. So this connection pooling, management of the connections, so the database will not be hammered with every possible connection. So all
Okay.
things with the network connectivity that people usually either put into their applications, those
Mm.
those the techniques of optimizing connection pooling, all these things were part of your application.
Mm-hmm.
Now, as you can see here, we already talked about this multiple things in on the screen. We didn't talk about security. Security is also very important, so that's why we put it as 1, 2, 3, 4, 5 as a number 6 on our list.
Okay.
Um, and if you cannot monitor something, or if you cannot measure something, you cannot control it. So observability bit is also important, right? So
Mm-hmm.
the how you would observe this, you need to put some additional libraries inside your application. You put the metrics library, you put the tracing library in your application, that
Mm-hmm.
allows you to integrate with third parties. So multiple things developers needs to do in their
Mm-hmm.
app. Does it
I
look
want.
like a microservice to you now, Whitney?
It looks like they're like what's left for the application logic. If it's like a little bit
Exactly.
of logic and like the rest is all like how to connect to everything else in the system.
Exactly. Exactly. So
Um, I want to give some attention to the chat. We have some great chat happening right
yeah,
now.
let's do this.
Fuel Snobble says that they never get to build the stuff; they get just inherit stuff. from other people. So like, so feels almost like right now somewhere in the world there's a distributed cluster that I'll inherit someday.
Oh
Um,
yes,
Cor-
aren't we all?
Kormaju has a question, but maybe we'll get there. So does Kuma support application communication on layer 7 and layer 4? So we
In
talked
answer is yes.
about the different OSI layers last week. Short answer is yes. And layer 7 is the application layer, and layer 4 is more like TLS, the UDP, TCP layer, correct?
Yeah, yep,
Yeah,
exactly.
just to get.
So those layers will require some of the like additional like a threading to specifically um, you will be able to distinguish some of the workloads when you're running on L7. So you will be able to do like introspection of whatever comes over the wire. You can inject like HTTP headers or modify headers to do some sort of like a transformation to the HTTP level. On TCP level, usually it's a stream of bytes. You don't have any notion in terms of like what those bytes mean, because that's why you need to go in the higher on the protocol level. um, so
And Code was Sean, making sure that I'm clear. I did say TLS when I meant TCP. So TCP UDP is layer 4. Thank you so much for helping us be
actually
clear.
I don't
No?
100% agree. I think the TLS, you can like wrap TLS like SSH like TCP on level 4, but it's semantic. I'm not
Yeah,
gonna.
yeah. And that's actually its own great point, because when Flynn was talking about the OSI model last week, he was just like, "Yeah, it's kind of messy in there. People disagree with what it is exactly," which is really not what you want in tech, but apparently that's
Yeah.
how it is.
Yeah,
Um,
so it
yeah.
is a yeah, so you basically, when you go in from the one level, from the like level 7 going down, it's just like all encapsulation, or like when you're going from down up, it's
Hmm.
encapsulation. You're putting some additional metadata, and when going down, you kind of like peeling off some of the some of all this kind of like information.
Okay, I like that
So
mental model.
you make the great point when you said it turns out that for actual application logic, we don't have much, right? So we
Yeah.
need to worry about all these things, all these libraries, all these integrations with the things. Like, where's the logic, right? If you
Where's the
think about it.
logic? Yeah,
Yeah,
yeah. Or having to make your developers like feel snobble, think through all these things when everyone's having to think through the same problems. It feels like it should be solved on a different level. Um, but I have a question too about Kuma in particular. Like, when, where in the timeline did Linkerd, apparently Flynn said it was the first one.
yep.
Like, where did Kuma come in the timeline, and why did Kuma get created in the context of other service meshes? Like, what
Um,
problem in particular is Kuma solving?
yeah, great question. So um, Linkerd 100% is pioneering some of those ideas.
Hmm.
And if you remember, the first version was actually in Java, or actually technically Scala. And after that, they realized that, okay, so there's a lot of things going on here.
Hmm.
And those things are not necessarily needs to belong to applications. So they took these things and make them as a like separate binary.
Yeah.
And this separate binary that will be running next to your application, it will be running on the local host. The latency between the applications will be low, and the communication between the where the mesh comes from. The communication actually happens through those kind of like smaller components, the binaries that will be running next to your application.
Okay.
And Linkerd, they went the route of creating their own kind of like a small proxy, the
Uh-huh.
system that will be able to provide all the things with the service discoverability, connection between apps, like centralized configuration, all these kind of things. um, but there's another group of people in another web scale startup that time. Now it's not the startup anymore. In Lyft, they created this super fast proxy called Envoy.
Okay.
And one of the cool things about Envoy is that it is, first of all, configurable through API. you will be able to change configuration on the fly. You will
Mhm.
be able to enable all these things. You will be able to observe what happens on the proxy side of things. So you will be able to collect metrics. You will be able to collect all the things. You will be able to have, say, encryption of the communication out of the box because it was solved on the proxy side of things.
Okay.
So we coming into a world where we have service meshes that either will use sidecar. Everyone is using sidecar these days, kind of like a second
Mhm.
generation of the service meshes. First generation, your sidecar is part of your application, those libraries that we were talking about. Second one, we
Mhm.
have an external sidecar. And at the time when the Kuma came about, there was already a few implementations that were existing, and probably the most known is Istio.
Mhm.
Uh, Everything that comes from Google usually have a buzz in the world, so they get some free publicity. And Istio uses Envoy as a sidecar as well.
Mhm.
However, there's an interesting. Um, I'm not saying it's contradiction, but this is an interesting story that happens in our the world. We love Kubernetes.
Mhm.
Everyone wants to be on Kubernetes. Everyone's claiming to be
Mhm.
on Kubernetes. However, there's still um, hard dependency on Kubernetes. You need to change
Uh-huh.
a lot in your infrastructure. And say technology like Istio would say, oh, is it me doing this? Like how?
I don't know what
Oh,
just happened. Yeah, okay.
yeah. Let's
Up.
see. No, no. Oh, yeah. So it looks like some gestures available in the new update of operating system. So yeah, so I was talking about Istio, and the people start looking to Istio, but Istio what created a very hard dependency on Kubernetes. Istio
Okay.
configuration was relying on heavily relying on CRDs. You need to understand some of the things about Istio in order to like understand things around Kubernetes in order to do the Istio stuff. So the first
Mhm.
thing, just stable for a second. Second thing is that mm, um, multi multi-region deployment. Kubernetes distributed system. You can deploy this across multiple different locations. I need to find a way how I can stop this because this is annoying. Okay, I found this. So if
While
you
you
have
do
a
that, I would like to say hi to some people in chat. Bucky Buck's here.
yes,
Hi, Bucky Buck. Thank you for coming. And then we also have a question about this is probably jumping ahead by a lot. So we talked about Envoy sidecars and the quick question of whether the Kuma supports complex OAuth 2 authentication.
LinkedIn user. Unfortunately, we don't know who you are. We need to table this question because I don't think it is right thing to do on the service mesh side of things. But we can talk about when I will explain everything. We can talk about some of the design patterns of implementing the distributed systems in the world of gateways, service meshes, Kubernetes, and other kind of things. So let's table this question for now.
Exciting. Cool. So we're saying Linkerd doesn't use Envoy. We want something that uses Envoy. Istio has a hard dependency on Kubernetes. And then you were starting into something else before we got distracted.
Yes. We talk about distributed nature of geographically distributed nature of Kubernetes clusters.
Mhm.
So
Okay.
think about this. We want to. Everyone wants to deploy the multi-region deployments. In one of the region will go down. We have ability to recover or somehow move the traffic more to healthy location. Uh, but all this architecture create a complexity that your application needs to be taken into account. So you need to have some sort of
Mm-hmm.
like load balancers that will be send the traffic in case one of the region will go down. So that needs to be automatically switch and send the traffic to another location.
Mm-hmm.
And all these things you need to take into consideration.
Mm-hmm.
Um, and One of the things with the that comes as a kind of like a side effect of the having dependency on on Kubernetes is that there's a lot of background that needs to be covered.
Mm-hmm.
So when the Kuma was initially created, there was three ideas that needs to be part of this kind of deployment, and why Kuma was conceived basically. Um, First of all, is developer experience. We wanted to have a service mesh that would be very user friendly,
Uh-huh.
meaning that you can start like very in minutes. Definitely Kubernetes helps to do a lot with the user startup, because Kubernetes allows to do a lot of automation. However, not everyone, I know that's shocking, and we're talking this in the on the CNCF world, and we're talking here as well. Shocking, but not everyone running their workloads on Kubernetes. Um, of course, we know it's the best platform to run your apps. Notoriously difficult to start over. You need to have either some sort of um, the vendor specific implementation. You either rely on whatever managed service provides you, or you have a very rock solid implementation of the Kubernetes things like Tanzu or like OpenShift that you will be installing in your organization. Some people not ready to do this leap. They want to run
Yeah.
these VMs, and they have tons of VMs. They want to run this. We want you to run the service mesh there, and the people will, kind of will be happy with running this. Um, so we call it universal mesh, meaning that this mesh can be run in Kubernetes, it can be run in VMs, it can be run on bare metal, what have you. So that's what we
Oh.
call universal mesh. And a third thing is, I already touched this with the problem statement, is that we want to run multi-zone deployment, and we're providing the ways how the people can build geographically distributed systems. So the third point with Kuma is, multi-zone, multi-mesh deployment out of the box.
Mhm. Works with geographically
Yeah.
distributed.
So
These are,
we
yeah,
wanted
yeah.
we wanted to create environment that will be not environment. So we can create infrastructure that would be unified across all this. If you think about this, if it's universal mesh, can you connect Kubernetes, your apps running in Kubernetes, and your apps running on VMs? And the answer with Kuma answer is yes. You will be able to create a unified environment inside inside this mesh, where you will have universal discovery. Service mesh comes with the service discovery through built-in DNS. It comes
Mm-hmm.
with a unified policies for managing traffic. Say you don't want to create connection for each application if you need to cross zone or cross region, and you can have a ability to manage how the traffic will go through the, we call it zone ingress and zone egress components. So all these things would be unified once it's deployed within the platform.
What was the words you said? Universal discovery and the second thing that you just described,
Declarative traffic policies,
declarative traffic
or
policies.
yeah,
Yeah.
yeah.
And then we have a question. Multi-cloud via VPNs.
So no, um,
Okay.
the service mesh provides capabilities that will taking care of this communication. You don't need to deploy this through VPN. As long as there's a connection between the system, you can put this the component we call it like zone ingress and egress. So we will be able to control outgoing and incoming traffic through the things that is important. And security, the benefits of security, kind of like automating the ways how the connection will be secured. We like to talk about the concept of zero trust, meaning that how you would identify the service is, um, is good or bad for the system. And one of the approach to do this is kind of like we will consider everything as bad. We don't trust
Uh-huh.
anyone, and
Yeah.
only those systems that we will put into kind of our declarative policies will have a ability to invoke other APIs, have a communication with other systems. And these days, service mesh, not only Kuma, many service meshes they used to implement this concept of zero trust, which is again, you cannot buy zero trust. Zero trust is the set of the procedures that your organization needs to enforce. Plus, you can automate other procedures using the technology that we're talking about.
So I love this. What I crave is what did you call it? A Webster's dictionary definition of like Kuma is blank. Do you
Yeah,
think we can do that?
Kuma. Yeah, I think Kuma
Cool.
is a universal control plane for your service mesh.
Oh.
Since technologies like Istio and Kuma and some others, they use Envoy as their data plane proxy or as their sidecar proxy.
Mm-hmm.
The secret sauce, when I say secret sauce, I'm just doing air quotes because there's no secret there. It's open source. You can go and see all the secrets. But all these things, how control plane communicates to data plane, will be solved on the control plane side of things. And that's why I'm saying secret sauce is actually in control plane. How the policies are structured, how many steps you need to do to enable certain capabilities. So that's why control plane is the heart of the service mesh. Since the service mesh will be relying on some external components like Envoy to do configuration, it needs to have some sort of like built-in ability to do the thing. So that's why the control plane is essence of um, of the source mesh.
Love it. So, so I'm loving this. I'm totally getting what's value and why it exists. I love it. Is there anything else you want to add to this definition before I draw a box around it and things are very official and can never be changed? I'm being
Love
sarcastic.
it. Yeah. No. Um yes. So I think it should be all right.
Okay.
I can definitely check official name.
Oh, you would
Um
make
but
sure we're in line
I
with its
just I just
marketing
no.
department.
I just checked this and my definition is perfect. If you
Great.
remember the quote um from the boys TV show, it's
What's
perfect. Perfect.
fascinating about like I do this kind of explainer regularly, and what's fascinating about the definition is like the definition always, like if we heard this first without all the context, like technically we understand it but we don't really get it. Like it took you explaining like, oh, it's really valuable that can be used with Kubernetes and VMs and bare metal, and it's really valuable that like geographically sub distributed systems can use it, but like, so I wouldn't have appreciated it if we started the episode with that. But now with all the
I
context, I'm like, this is really cool. Yeah.
I probably it came in naturally through the years of of trying to explain complex things to people. And one of the things that I appreciate how the things were explained, it's actually outside of the world IT at all. I This year I attended I love fitness, and I attended the class for CrossFit level 1 coaches as a basic level that you need to attend and pass the test in case you want to be the coach in a CrossFit.
Uh-huh.
And the
Nice.
CrossFit has a definition.
Uh-huh.
CrossFit is the constantly variable exercises performed, functional exercises performed in the high intensity. And you think about this, that's the definition of the sport. It's
Uh-huh.
constantly variated functional movements performed in the consistent or like on different levels of intensity.
Uh-huh.
But you can take every word and break this down, every word, and put the as a diagram. Same here. Kuma is
Yeah.
universal. What does that mean, universal?
Yeah.
Kuma
Uh-huh.
universal control plane. What's the control plane? What's the, like for your service mesh or for your application connectivity? That's the
Yeah.
That's the beauty, kind of like trying to pack very complex thing into one sentence that you
Yeah.
can use this. Remember our starting conversation about how you would,
But
what you can say you're doing here.
yeah, and it's a
If you,
problem that's
yeah,
specific to every technology. And it's a problem as a learner when you're just like, I just quickly want to know what something is. And you read a sentence and you don't know the deeper meaning behind every word.
yeah.
You'll almost need every technology should have their definition, but then also a diagram. Like, this is what this phrase means.
One of
Because
the
it is all very well thought out. Yeah.
one of the things that I like to do in my work as an educator, as developer advocate, is give people enough context
Blue is.
to lift them
Mm-hmm.
up in their understanding, so we can start having conversation on the stem level of abstraction. So providing the some sort of like a basis of the things, so we can have a conversation about the things that I wanted them to talk about, I want to explain them about, but they also need to have a bare minimum to understanding.
Yeah.
um
We have some questions for you in
yes,
chat.
let's do it.
How is the private key insert rotation experience in Kuma?
Yes, so one of the components of the secret sauce of the control plane
Mm-hmm.
is that control plane is responsible, it's a brain of your operation, it's a brain of the
Mm-hmm.
system. And there's lots of responsibilities that this control plane will take. So first of all, like consistency of configuration, making sure that every component, every data plane that runs inside our Kubernetes, our service mesh, is healthy, get the latest and greatest version of the configuration, so we have a consistency. Another thing that through this is a kind of like another side effect is that automation. Control plane inherently will be doing a lot of automation on the sides of the data plane. It needs to be shipping configuration, so your data plane will be reconfiguring, different routes will be changing. You can have a very cool topologies of the how the traffic will flow through. And one of the things is that control planes provides it's to be in certificate authority, since it's already brain, it's already
Mm.
owns some of the notion of the kind of like a source of truth. It also can be authority that will be providing the um, um, remember the fifth element, little Dallas multipass. So provide for every service this multipass, that the service has this passport to access other services inside the control plane. So uh, control inside the service mesh. So control plane will be issuing certificates that will be distributed across these data planes, and this rotation is matter of like seconds. So if you have hundreds of the services, um, that you will be able to send updated certificate in a matter of seconds. One of the examples that I like to bring when we're talking about this particular topic. So at Quant, we built Kuma, and we also donated Kuma to CNCF, and also we use this internally for building our own the cloud product. So internally, it's the we use this, and one of the reasons why they want to use it, our engineering team, they wanted to have a MTLS um, across the system, because it is a requirement to have some sort of data in motion encryption whenever you're providing some sort of public service or managed service. It is
Mm-hmm.
part of the requirement that
Mm-hmm.
some organization asking for public services, and we were able to implement this within days, and we change the time of rotation of those certificates between the services into kind of days, into minutes. It's incredible
Ah,
productivity boost for the teams whenever they're looking just to simply enable data in motion um, encryption. So
cool.
answer, it's not the so short answer, but it is a answer. Yes, it is easy certificate in key rotation that handled by control plane.
Handled by the control plane, which is a great segue into to Kormaju's question. So it's what's data plane versus what's control plane, and what's the role of data plane and control plane proxies? Um, Can I
I think
give my
yeah,
beginner's understanding and you can tell
yes,
me how wrong I am?
absolutely.
My
No, 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 no.
understand
You probably heard this
how
multiple times, and
I
you
heard
have
it
a
only once during the Contour episode, which was many months ago now. But it was uh Sanjay was our guest, and Sanjay said that the control plane is like the part that the human interacts with, and that's where you configure all of the settings that you want for the cluster. And then for Contour at least, like the data plane is what does the work of actually routing the requests. So control plane is where you do your configuration. Data plane is what's actually moving the requests around. Is that correct?
it is
Probably.
it's very much correct. I'm very visual person. That's why I'm enjoying, the things what you're doing with the light boarding. But also, I like to bring some metaphors. And one of the metaphors when I would like to talk, when I already said control plane is a brain.
Mm-hmm.
So essentially, control plane it is a brain of your operation. Say you have a
Mm-hmm.
two people they need to interact. You need to tell someone to do something. You need to tell someone to okay, so pick up the pen and start writing. So your
Mm-hmm.
brain will send a signal to your through your neural system to different parts of
Mm-hmm.
your body. Pick up this. So as a human we can understand certain commands, so that's why
Mm-hmm.
when someone tell us to do something we can understand this, but our brain can actually translate it into the world, into the language that our neurons will understand and send the signal towards the hand. Same thing with the control data plane type of mentality. uh, as a operator we send some sort of the predefined command to control plane,
Mm-hmm.
so control plane will interpret this and will send more more information that will be required to data plane to perform particular action in the world of say like the API gateways, or like let's talk about Kubernetes. Kubernetes also has the concept of control plane and data plane. Control plane, this is where all Kubernetes configuration will be stored, and your data planes, that's actually where you will be running actual workloads. Where your kubelet is running, this is on actual places. So that's why control plane will be responsible for handling configuration and managing configuration, and data plane will be responsible for actually doing the thing. In the world of
Mm-hmm.
Contour, which is API gateway, um, uh, you can have a separation between control plane and data plane. Sometimes this there's no separation. Sometimes some of the projects they come with the control plane data plane mixed in. So that's why. So if you take the Envoy, for example, Envoy provides the API for configuring, so meaning that configuration API is built in, but also it provides the ways how to proxy your traffic. You can also have a control plane that will be separated from your data plane that will be running your traffic, and control plane will be only sending commands here.
Mm-hmm.
I hope it makes sense to Kamaraju.
So is it? So I wrote on the board: control plane's the brain. The config is set here at the control plane by the human, and the control plane in turn configures the data plane. And then I wrote
Precisely.
data plane. Okay, great. Data plane's responsible for actually doing the thing. When I say doing the thing, do I mean routing requests, or are there other things it could be doing?
If we're talking about in a generic term, control plane,
Uh huh.
data plane, it can be anything. So whatever
Okay.
you're controlling, so
Okay.
that's why you're doing the thing. In the world of the service mesh and the API gateways, yes, it's the responsibility for actually pushing bytes and the routing traffic, um, encrypting uh, payload, um, do header transformation, request transformation, add and removing headers, checking if the GWT token is correct, or
Mm-hmm.
JOT token, I guess. So whatever is your controlling, whatever is required for your system, um,
Mm-hmm.
say like if we recall some of the Kafka past, we build the Kafka as a service. and control plane was responsible for spinning out and the killing Kafka clusters. There was a control
Okay.
plane that was managing where these clusters are deployed, like how to manage them, and it was responsible for half of this and the sending commands. Hey, are you alive? And the cluster data plane, actual cluster, will be responding back. Same with the control with the service meshes. Am I going too deep? Just
I'm interested in but I think it's great. I appreciate from Koramaju the reminder to level set. It's sometimes hard in this show to like technically we talked about this on the show before. Should we do a refresher?
yeah,
So it's good. I really appreciate the question. And so if
yes.
anyone along the way, if there's anything you're not catching on that we're not explaining, please ask. We're so happy to talk about it. Um, for the benefits, so we have universal discovery, declarative traffic policies, the security. So we have automating the act of securing connections. I'm noticing that maybe observability, nothing about observability is mentioned in the benefits so far.
One of the
Do you want
things,
to put
yes,
something
of
there?
course. Well,
Mm-hmm.
yeah, we need to put this three pillars of observability. We need to collect
Uh-huh.
the metrics to understand what is happening with the system right now. We need to have a collecting logs to understand the past, what has happened, and we also need to collect traces to see how different components of the system interact to each other. So having this information centralized, collected on the data planes, collected on your apps, it's very crucial. One of the things
Mm-hmm.
that I like to say, if you cannot measure something, you cannot control something. If you don't
Mm-hmm.
know what's going on with your system, especially if you're running distributed system, it would be very difficult to identify the problems. How you would know when the users will call on you and saying, "Hey, we cannot seems to log into our," or like we were able to log in, but we have a instead of a list of our transactions, we see kind of like a 503 error, whatever.
Uh-huh.
So how we as engineers who will be supporting this system, how we can identify this. So having the observability component is absolutely crucial. And but I will say but a little bit after, because sometimes people trying to oversell benefits of the service mesh. They get too excited about this. Hey, you're getting the observability out of the box, and you have some fun things. You need to modify your application, blah blah blah. Certain things will require you to adapt your application for those environment, but in
Uh-huh.
general, for the basic user experience, simple demos, you will be able to enable observability out of the box, start collecting metrics. You can see how long it takes this request to be served, and the system will respond and things like that. So that's just absolutely a benefit of having um,
Okay. Should I
absolutely, yeah.
write enables observability out of the box, or is that too lofty of a, like you said, in a simple scenario, it does. Should I
So
just leave it alone and put a
no,
box around
observability,
benefit?
absolutely, it's a
Okay.
benefit, absolutely benefit.
Uh-huh. Just observability.
Observability, and you can put the metrics, traces, and logs inside, kind of like a in the brackets, or like as
Yeah.
a part of the observability, like whatever you're getting. Um, and it is, again, it's a part of kind of in generic terms, automation. So some of the things that service mesh will bring into as a
There we go.
benefit, like
Mm-hmm.
automation of the things. Not necessarily observability, but in general, you can automate a lot of thing that will eat the time of operations team.
Should I write observability automation?
Observability and automation as a separate item.
Okay. With your permission, I'll leave automation off because it's too general. Automating what? And then we're
Automating.
going down a whole rabbit hole.
Yeah,
Okay.
if needed, we can talk about this. One of the examples that I provide, automating the certificate rotation. Some of the things that is
Okay.
part of kind of security, but in the world without service mesh, usually it's performed either through some automation scripts or some sort of like a system that needs to be taking care of this. So yeah.
I like it. Excellent. What's next?
So remember, at this point of the stream, you should ask Victor. Okay, but what about application? We start talking about the all these things. Where's the application? Where's the code? Where's the code?
Where's the
Yeah.
business
Uh,
logic in all this? Yes.
Exactly, exactly. So, and we sort out all the infrastructure bits. So when we run our application in this infrastructure, in this environment of service mesh, we will have automatic benefits. So we don't need to include those as a part of application. You can focus on
Mhm.
your application logic. You can ship this as a container if you running this in a containerized environment in Kubernetes world. Um, if you running this in VMs, you don't have to do this. You can run this as just like a operating system process, like a native application or like a
Mhm.
whatever application you have, and just to deploy this and enable uh, data plane next to your application. All the traffic that will go to this node will go first to your proxy, and after that proxy will be responsible to send into application code.
So you can run it as a sidecar in a Kubernetes pod.
Yep.
You can run it as an operating system process. Is that what you said?
Yes. So it is like a typical deployment structure. Definitely, Kubernetes popularized the concept of a sidecar pattern
Uh-huh.
by providing this, automation capabilities. But in general, uh,
Mm-hmm.
sidecar pattern doesn't have to be, containerized. Some of the things. Whenever you're running a process next to your process, and this process will be responsible for you interacting with inside world, that's the sidecar. Um, the Usually people sometimes there's kind of misconception between sidecar and ambassador, right? The pattern when the
Okay.
kind of like someone will represent you. So in this case, the sidecar also can be ambassador because it will also represent your service because you're going outside through the egress.
Uh-huh.
But anyway, um, that's it. So when we're running this in Kubernetes world, it is the most you will get the most benefits through the Kubernetes magic. By magic, I mean just Kubernetes automation. You have your namespace. You put the label in namespace saying, "Hey, sidecar injection true." So, and every pod that you will be deploying in this namespace will include sidecar. Um,
Mm-hmm.
the control plane will be responsible for in order to establish secure communication between control data plane, you need to generate token. This token needs to be stored inside the control plane and used to sign every request that go in between control plane data plane. And after that, whenever connection is established, you will be able to send the communication. You will be able to establish secured communication between the different application nodes. So Kubernetes does a lot of automation by simply putting this sidecar injection through as a
Mm-hmm.
um, as a configuration for your namespace. And for your apps, you just start using this. You immediately, whenever you deploy this in Kuma,
Mm-hmm.
one of the things that we mentioned in the very beginning why Kuma simplified developer experience. We also
Mm-hmm.
provide some sort of like a sane defaults for certain things,
Mm-hmm.
um, because we don't know how the people will be running applications and where they will be running applications. We also like to include some of the out of the box policies. One of the
Mm-hmm.
policies would be automatic retries.
Mm-hmm.
Before you start thinking about this, service mesh like Kuma already will get you covered, and there will be some of the automatic retries. Say every request can be retried for 5 seconds with the how we call it, exponential backoff, and all these kind of things
Uh-huh.
that would be predefined and ready to use.
So
Another yes,
I want to back up and make sure I'm
yes,
following before you move
yeah,
forward any further. So we talked about different ways Kuma can be run as a sidecar in a Kubernetes pod or as an operating system process. And so I imagine with VMs and bare metal, we're talking about the operating system process there. And then we started talking about how the application developer doesn't need to write anything into their application. So my question right now, before you move forward, is does is is it safe to say like period, an application developer doesn't have to put anything in their application, no matter how Kuma's run, no matter whether it's Kubernetes VMs or bare metal, like it doesn't, the developer just doesn't have to do it.
There's one exception probably that is that will come in the world of distributed tracing.
Mm-hmm.
So the way how distributed tracing works generally, it is every request will include special type of the header that with this header will be propagated with the request.
Mm-hmm.
If we need to call one service, needs to call another service, and this another service needs to call another service, blah blah blah. Um,
Mm-hmm.
so application technically doesn't need to be kind of like implementing all these things, but
Mm-hmm.
propagations of the headers is important, thinking that your application needs to be aware that it
Mm-hmm.
runs in an environment where application code needs to be propagating. For say you have a one microservice that exposes some of the functionality through the REST endpoint, but also it will require some of the functionality to perform this. Say we have a customer portal, and the customer portal will get there would be another microservice that will get the customer the I don't know, figuring out address based on geographic coordinates, or vice versa.
Mm-hmm.
So we need to invoke this microservice. So whenever our microservice will invoke, we need to also make sure that we propagating a headers in order to we know that this is the part of the same request, so we will be able to capture this information. So this is very kind of like a very kind of a niche use case, but it is important use
Uh-huh.
case that you need to understand. And
Mm-hmm.
apart from that, in order to um, the application to operate in the service mesh environment,
Mm-hmm.
it doesn't have to change anything. You don't need to put any knowledge inside your application. I have this experiment that I did myself. Google Cloud Platform um, has this GitHub repository called Microservices Demo. This is kind of like a thing that they develop to demonstrate some of the bits of Google Cloud Platform and Istio. And in order to prove the point that when I run this in the service mesh, well, it will not require modification of your application. I just took
Okay.
whatever containers they have. I changed
Mm-hmm.
the configurations instead of Istio, run them in Kuma. Technically, I,
Mm-hmm.
I I just like changed the namespace sidecar injection instead of like injecting Istio sidecars. I was injecting Kuma sidecars, and it worked. And
Mm-hmm.
immediately, I was able to collect the metrics, traces. I was able to collect logs. I was able to enable MTLS in my system. So short answer is you don't have to change your application code in order to this to work. There will be small like here and there side side effects that you might need to do this, but in general, the promise and kind of like a selling point of running things in the service mesh is that you can just enable this environment, um, and your apps doesn't have to know anything about this.
So, is there a reason you would want to run it as an operating system process in Kubernetes instead of a sidecar?
So it's all about your deployment strategy, I would say. um, when we deploy this inside the Kubernetes as a sidecar, we have one cool benefit, actually two. Whenever we run the container inside the sidecar,
Mm-hmm.
or sorry, a container inside a pod, these containers inside one pod, they can share network, they share local host.
Mm-hmm.
So there's no need to do any like a routing or service discovery. We don't need to go and asking for DNS, and this allows us to configure actual routing for our sidecar. When we're running this, running this as a pod, we can also share files between the systems. So the configuration, um, or communication between sidecar and our process, basically negligible if you compare running your application next to operating system process. Another, like, negative thing, if you want to run this as a operating system process, you need to create these containers yourself, and you
Mm-hmm.
need to make sure that configuration that will be configured inside this container, because you need to include
Mm-hmm.
your application, and you need to include Envoy binaries together with your application. And this is where you need to rely on consistency, that your operation people will provide different, like, same version of Envoy that this system is required. When you're running this as a sidecar, control plane will be responsible that it will run particular version that it was suited for this particular thing. So short answer is definitely you could, but, like, why would you?
Okay. So it's easier to install as a sidecar, and then Kuma shares the network with the app container.
Yep,
So, which is
yep.
part of why it's easier to
uh,
install.
yeah,
Cool.
Envoy shares, not Takuma.
Ah, yes.
Yeah, because we're running this in
That
it's a yeah, data plane.
that actually, maybe it would be a good idea then to draw a diagram of
Yep,
what's going on exactly.
yep.
Um, how do you think we want to do this? Do we want like more than one Kubernetes cluster, just one Kubernetes cluster? What's happening inside it?
We can start just one Kubernetes cluster,
Okay.
and we'll see how we can go about this. So let's put the, I don't know, 3 nodes, whatever, 3 nodes Kubernetes cluster.
Do the nodes need to talk with each other, or are they just like, should
I
I
mean,
stack them like this?
yeah, no, I mean, it's just like actual Kubernetes nodes that we're running. You don't have,
Okay.
they will be interacting to each other. Yeah,
Okay, that's the question.
just 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 to put, yeah.
There's so many different ways that people show a Kubernetes cluster that it's
Um,
yeah. So we're
it
gonna do
is
a 3 node cluster.
very fortunate that I did drew some diagram
Oh, but you're
literally
not
this
allowed to
week.
screen share. There's a hard rule on this show.
Yeah,
It's
I will
it,
text it to you.
okay, you can give me the link in the private chat and I can put it
Yeah,
in, but
yeah, yes. I will
we're
so
ruining
you will get the idea what I would like to talk.
uh I kind of like the exercise of you having to communicate it to me.
Yeah,
Does this
okay.
seem good enough for
Right.
cool for our purposes?
Um can
Or
I
you can, yeah,
can I ask you to do this like one more time? So let's
yeah.
start not from the Kubernetes. Since I was talking about
Okay,
this is universal, let's start with app. Say
okay.
you have a 3 apps. Call it, I
Three
don't
X.
know, the customers. We have the products, and
Uh,
another one would be, I don't know, like some product catalog. I don't know, the system that would be doing like a currency exchange. So it's our application.
okay.
Microstore is one. And
Up
say, in
to
order to call, to get the response from the customer's information, um, you need to say for the
cart.
products, yeah, cart. Okay. So as a customer, you need to put the products in the cart. So there would be some sort of like a communication between them, right?
Okay,
Between the
yes.
two applications. So those things are for the simplicity, for the sake of this. It really doesn't matter how you deploy this. It's some sort of application container. It can be WAR file. It can be container in terms of Docker container. It can be the just a zip file, RPM package, whatever. You deploy this application somehow. Now,
Mm-hmm.
in the kind of like a next to each application, we will have this the data plane proxy, this sidecar
Okay.
the component, and you can deploy them kind of like as a small, yeah, perfect, yeah, as a small, but and you picked the perfect color for Envoy. That's, it looks like the purple is the official color of the logo of Envoy.
Okay. Cool, cool, cool. Yeah, actually, yeah. I guess because maybe I already knew a little bit, but it's Lyft, right? Lyft created it, so this is also
Yeah, that's
the
correct,
Lyft
yes.
pink. Yes. Okay.
And now our communication between those systems become,
Uh-huh.
so you probably want to, okay, so on void proxy on the card service, you want to put this on top of the service, and the product,
Okay.
you want to do this on the bottom and the customers on the bottom, because I want to show that the
Okay.
communication between the services will be happening through the data plane proxies. So that's why instead of like having the lines across the different places, I want to have a lines uh, will not intersect to each other. Yeah.
Okay.
And you
So
put the, yep,
basically,
perfect, yes, fantastic,
yes.
yeah, exactly,
Cool.
perfect, yes. And now say whenever we need to call, say on the customer side of things, imagine you have a route called slash customer slash all, for example. You can inside the
Mm-hmm.
inside the box of the customer,
Mm-hmm.
uh you can put, you can use different color of the market, just to say you have a slash customer something, and then slash cart slash items. Yeah, like I want to demonstrate that this is a web service and it has a URL and it's a part of URL, like slash cart slash something.
Okay. Got it. Uh,
It can be
URL.
whatever, yeah, it can be whatever, yeah, but part of the
Hmm.
route.
Victor.com/cart.
Yep.
Cool. Listening.
Yeah. The same thing on the products, and the same thing yeah, I don't think you actually need to put the like we can. Oh, okay. I think I got it. I can, instead of victor.com, let's put
Uh-huh.
this different one. So inside, let's talk about the discovery. Inside service mesh, a control plane provides the ways how we can discover the services. So
Uh-huh.
this application will have a distinct URL. So we call it products.mesh.
Okay.
Every
So,
service
mm-hmm.
or cart.mesh slash like items. So in every service, in this case, customers.mesh
Mm-hmm.
will have uh, so dot mesh. This is the special type of domain that will be available across service mesh. So you will
Ah.
always, regardless where it is deployed, and think about this,
Okay.
this customer.mesh can be deployed on VM, your
Uh-huh.
products.mesh can be deployed in Kubernetes, and your cart.mesh can be deployed on bare metal. But for application connectivity, your application doesn't really care. So the service always will be available through this URL within the mesh.
Okay. Uh,
And that's the mechanism of the service discovery that provided by control plane of Kuma. Yeah.
discoverable URL.
Yeah, and obviously, it's a DNS server that runs inside there, um, and um, you can customize this. You can have a different URL for a different kind of like zones on the different regions and things like that. So you will be able to have. There's a kind of concept of location awareness For example, you want to have ability that your database deployed. You don't have to draw this right now. I'm just like giving the concept of this kind of how this all play together with the discoverability and the multi-zone deployment. You might have deploy your service that would be next to your database. So you every time um, you call, you only will be calling for the local data. Um, and when the request comes in, there will be gateway that will be routing this to the particular zone of the meshes. And after that, if this system will go down, this gateway will be reconfigured and send the data to the backup site and things like that. But for application purposes, you don't have to do anything. You will still have same kind of like a constant URL and things like that.
Okay.
Now, say we want to have add some products information inside our cards, so the communication will be happening here between data plane proxies, and whenever you will be calling a products.mesh inside the service products mesh, or no, inside the card.mesh items service that need to get a list of the products, you will be calling Envoy. You will be calling this data plane proxy.
Uh-huh.
And data plane proxy will be configured with the list of whatever is available. So it will know where to find this product. So this is how discovery will work. Also, the communication between those systems, between this like purple components, can be also encrypted. So you don't have to encrypt communication between your data plane proxy and your application because it's a local host. Like if something is happened on this side of thing, you have a bigger problems rather than someone is breached already. But communication between these Envoy proxies is also encrypted using MTLS, and it also provided with this. So I think you need to also draw some sort of like a distinct square that will be identify actual control plane that's running.
Okay.
You can pick up some other color, maybe like blue or whatever you have.
Blue doesn't
To
show up very well. I'll do a
Yeah,
green box. So this is
yeah,
our Kuma
green.
control plane?
Yes, exactly. And it can have like a small cylinder that will represent database. Essentially, it's the
Okay.
database where you store all the configuration. In case of failure of the pod, this configuration will be restored from the database. It's persistent in Kubernetes. Yeah, exactly. So the configuration is persisted. You can store this in external database, or when in case of Kubernetes, it stores in its CD, or whatever.
Config DB.
Yeah. Now, since we have a little bit of the room down below, we can actually add another component here. So when I said Kuma was designed to be in distributed geography, we need to talk about the concept of the global control plane. So you can actually deploy one global control plane that would be maybe not necessarily needs to have any data planes to measure, but this global control plane will be sending this information to zone control planes. So you can put another green square down below and put the I don't know, like a crown, put the crown and call it a global control plane because
Is it
it
all
would be,
is it also Kuma?
yeah,
Okay. Uh, let's see if I can.
perfect, yeah,
Yeah, I wasn't sure I could do it, but there it
yeah.
is.
You
And then
call
it
it
also has
like
its own
it's a Kuma and call it GCP. It's a global control plane.
I'm going to write out global control plane because GCP is very much Google Cloud Platform in my head. So it has its own config database. I'm making an assumption here.
So no, it can be it's a kind of like a deployment details, but it is, yes, it's some sort of storage where the data is stored, because this is kind of like a brain of the brain, you know, kind of like
Okay.
again, you might have your central nervous system with your brain, and you can have a peripheral nervous system with your kind of spine brain. So think about this like a global control plane is your brain, and your spine brain, the the it's going to be a zone control plane. So you can,
Okay.
and now you can have multiple things that you have on the top. So you can have a
Hmm.
multiple zones that deployed like this, and your global control plane will be responsible for moving things around. Or what we can do,
So
you
this is a
actually
zone,
can, yeah,
right? Yeah.
or you can we can separate these apps in the
Hmm.
zones and deploy each app in each individual. Now it will complicate things, because in this case we need to also draw here a zone ingress, zone egress. um, we will draw this like a small zone next to it.
Yeah. So zone one, but
Yeah.
then there are also
And
other
let's,
zones.
and yeah, somewhere here, let's have a one small app. Let's call it analytics, whatever. Let's call it analytics. And it will be available analytics.mesh as application. That will be,
Where's our
you want to,
where?
yeah, you want to do zone 2 a little bit bigger. You want to do this a
Okay.
little bit bigger, but it should fit one application with the yellow square.
Okay.
And also it should fit
Another Kuma for its zone.
yeah. But it can be smaller. It's just for demonstrating
Yeah.
that this, um, or reporting, it's easier to write. It's much shorter than analytics. Let's call it reporting, whatever.
Okay.
And you can use light green to say reporting.mesh or report.mesh.
Cool.
So in order to manage to manage traffic between those systems, um, we have this between two zones. We have this component called zone egress and zone ingress that will allow these zones to communicate. So, for example, if your products applications wants to call a report application, they don't need to have a direct connection. Connection will go through this like small. You can draw another small envoy square inside each zone. When we need to send the traffic
Mhm.
out, it would be egress. When we need to send traffic in, it would be ingress.
So two envoys or
It can be one,
okay.
and draw them closer to the zone, so you can put the lines, because they will be communicating through this like a zone ingress and ingress. Yeah, exactly.
Oh, this is fun. All right.
So, and now communication between two zones, actual traffic, actual the API calls from customers to reporting system will go through this proxy called zone envoy, zone ingress and zone egress. Now, you have a question?
Oh, I have a desire of what I want to do next, but you seem to have a plan too. So let me state my desire, but I ultimately trust you. Like
Okay.
what I want is now to tell a story about like a linear story about how all these things are going to interact with each other. And I think
Yeah.
so much so that I want to write out like step one, step two in
hmm
words. Even block my face. I
Before we
can put a
doing that, I
sleeping.
want
Yeah.
perfect. Yes. Before we doing this, we need to put one last component.
Mm-hmm.
Um, Also would be purple, but we will call it gateway. It can be on any zone. It can be on any zone. It can be on its own zone. It's also fine. Just put
Okay.
this in the bigger zone. In the bigger zone somewhere. In
Is it
other
getting in and out of the zone?
Yes. So
Okay.
outside, it would be kind of like a thing that would be getting traffic into the system. Perfect. Yes. I would
Okay.
not do this better. That's perfect.
Okay,
I
good.
wouldn't do it's perfect.
Great.
So and think about this, what the gateway allows us to do, and this is where you can put this like victor.com/customers, victor.com/products, victor.com/report. So
Okay,
this is
yeah.
on the gateway side of things. We can put the Victor in front.
Okay.
Wow. And now we can talk about linear. We can talk about linear representation of this use case. So
Great.
when the request comes in, we usually have API gateway in front of this, and API gateway is essentially if you again, I love metaphors and I like to talk about
Mhm.
metaphors. It's a bouncer. You're going into the club. You're going into the club,
Mhm.
and in order to check your credentials, you have the appropriate drinking age, you have a appropriate um, I don't know, attire, dress code, and things like that. In our case, we're gonna check the permissions, authentication, authorization. You have a correct JOT token, but also your request is properly formed. You can do some validation on the gateway side of things. You want to get the list of the products first. So when the traffic comes in, goes into gateway. Now, so this gateway is also part of the service mesh. Kuma has this concept of a built-in gateway. That's essentially another instance of Envoy. And for
Oh.
configuration of this gateway, Kuma implements Gateway API, which is hopefully, I'm really looking forward for some of the announcements that it will be going out of the beta. You
Uh-huh.
configure those routes using Gateway API, and
Mhm.
the since it's running in the service mesh, it has a context of how to discover these products. So Gateway knows every time you hit victor.com/products, inside Gateway will translate this because it's going to be products.mesh/products, and
Mhm.
Gateway will make the request to data plane proxy that will front our product mesh/products.
Um, cool. So it's a product request coming in.
Yeah.
Gateway makes requests to products microservice to
Yeah.
the proxy of products
Yes.
microservice. Okay.
And send the response back. Along the way, along the way, Gateway can inject, say, tracing headers, so we would know what is happening with this request.
Mhm.
And those things will be available on control plane. Will be collecting this and send this data into Jaeger to visualize and draw a dashboard.
So this Kuma instance is collecting the information.
Yeah. So okay. So technically, it is each node will be reporting to Jaeger, but when we configure this on the Kuma side, we're just defining the policy. We're saying that from the service A for the service gateway to the service product, we need to collect
Mhm.
the traces. So that's where we can declare this declarative tracing policies. Um, so at some point we might have our security and compliance people saying, okay, so we see that right now everyone can communicate to everyone inside this mesh. We need to have explicit communication that only uh, card service can invoke products directly, and only gateway can invoke product directly. So for example, customers cannot
Mm.
invoke products directly, and you will be
Mhm.
able to create this declarative policy. And
Mhm.
whenever it is not the case, we will just like throw error. Another thing that we can do, since we're already controlling the flow of the traffic, we
Mhm.
realize that we might have this reporting the service might rely on some sort of third party, or say products, or card service might rely on currency exchange. And currency
Uh,
exchange may be a very expensive service. We need to limit how many times we can invoke it. So
okay.
we can configure a rate limiting policy, um, uh, and um, and limit how much we want to call the services. So whenever application are deployed in this environment, we can do a lot of things with the flexibility and the dynamically reconfiguring different rules without changing application code or without even redeploying application.
Mhm.
And thanks to this environment, we do have we can deploy in another zone and say offload this. We feel that the card application needs to be deployed on. We have a customers on the West Coast. We have a customers on the East Coast. Let's deploy these card services on the West Coast. Let's deploy card services on the East Coast, and we will
Mhm.
have a global load balancer that will be running our request. We know that the request comes in from San Francisco. We can send
Mhm.
this into the card service that will be deployed inside the zone that would be closer to our users.
Is that happening here in the global control plane of Kuma?
So global
Or
control plane has all topology of what is happening in the system, and it is every time when our operator will want to communicate with our different zones, different meshes, it will go into global control plane. Global control plane for consistency will have a full snapshot of global configuration, and it
uh-huh.
would know how to send the configuration to zone control planes.
We have a question.
Yes.
Um, is Zone Envoy a gateway to communicate to each other? So we have these zone envoys that
Yeah,
that's
exactly. So
different from the gateway, or is
yes,
it the same thing?
it is different. So gateway, no, I mean like technically it's a they both gateways, but from perspective of vocabulary of the system, zone ingress not necessarily needs to be available for users to consume. So it can be only conduit to communicate between the zones. So short answer is yes. Zone ingress. This is what we use to communicate between zones within the service mesh.
Cool.
Um, I think that's pretty much it. From perspective of like all these things, and with this picture, we can also go back to our
Mm-hmm.
previous statements, the things that we already discussed, and put them into the perspective, um, and
Ah, fun.
explain all the things using this diagram.
Okay.
So whatever you want, you can pick some of the things, and using this diagram, we will be able to explain everything that we just we spent hour talking.
Okay, so I mean, do you want to go down this the service mesh list, do you think?
Yeah,
Or we
yeah.
could talk about these three Kuma benefits in terms of this diagram,
Yeah,
or
we can
these
talk
five?
about what the first one. Like, let's talk about this. So, the service mesh gives you service discoverability, regardless
Yeah.
where your application is deployed. You will
Mm-hmm.
be able to do this through built-in DNS system .mesh. Um,
Okay.
uh, that's how you will be able to do service discovery.
Okay.
So. connection between the application and different retries. So this thing is also handled on the proxy side of things, and whenever we feel that we will not be able to reach it, communication between different data planes programmatically will, increase the timeouts, increase the retries, and things like that.
So, so it's all about these three proxies talking to each other when in terms of
Right.
these three microservices. There's
Yeah.
no other way around it. Okay. So like
And
if this was a more complicated interaction, like if the call went to products, but the products needs to see what's in the cart to know the inventory before it can give a response. Instead of it going just here and back, it would go from here to here and then back. Yeah.
exactly.
Okay.
Yeah.
Cool.
We
Um,
have centralized control over configuration, so we know
mhm.
the control plane provides UI. I don't know why I didn't mention this at the very beginning, but people love nice UIs.
Uh-huh.
So every control plane, you will be able to have the visual representation, what kind of services running, what kind of policies enabled, what kind of data plane proxies are affected by certain policies. That's also very useful um, to know when you try to debug something. Oh, my policy is not applied. Like, let's see if you actually apply the policy for correct data plane proxy.
Mhm. So
Um, yes.
so I want to I'm not quite ready to move on. I'm still just wrapping around my head around one request. So we talked about if it
Yes.
was more complex, what that would look like. And
Yes.
then it also then it sends the response back and receives response. And
Yeah.
then you kind of answered this before, but I want to capture it. So as a human, I can observe this that happened through my Kuma, my zone one Kuma instance UI. Is that true?
As a human, you want to observe this on the global control plane side of things because you will have a
Okay.
view on all the zones that deployed.
Mm-hmm. Okay.
Yeah, as a operator or SRE, you will be able to use global control plane.
And then this will probably maybe this will take us there, but you also
Yeah.
talked about like, oh, if I want to put another instance of a cart app in a different zone or move this particular cart app to a different zone, that's an easy thing to do.
Yes. So whenever you have your deployment tools will stay the same. So, for example, like not to stay the same. In order to deploy this application on different zone, you need to make sure that you have an appropriate Kubernetes cluster. You have a right enough resources to do this. Once you deploy this, and they will be deployed across, and the service mesh is already configured, the card.mesh service will just appear, and the traffic will go just like immediately.
Does it?
Moreover,
Okay.
yeah, go ahead. Go ahead.
If it's a brand new microservice versus migrating one the system doesn't know about or that the system already knows about, is that the same type of work or is it different?
If we're assuming that we're running this Kubernetes, we just deploy this in the namespace that has enabled sidecar injection, and the microservice will register in the zone
Okay.
control plane, and you will be able to see this. It's not heavy lifting. It's just like another day in the office. Just deploy another microservice.
And adding zones and adding applications are each a relatively simple operation. Is that
Yeah.
with Kubernetes?
Yes.
Okay, cool.
Basically, everything will end up writing bunch of YAMLs.
That's
in uh, in either it's going to be kind of like the mesh configuration, which is YAML file. It can be form on CRD, um, or uh, or it's going to be some sort of like a label on existing resource, like a namespace or service or whatever.
Does every zone have a gateway?
If they need to communicate to each other, if the traffic from one zone needs to go to another, it will require to have a zone ingress. Um, if the traffic needs to comes in, someone needs to invoke this. If, say, my reporting system, my reporting application needs to call products for some reasons, it will require zone egress so the traffic can go out.
So,
And for application, and for
uh-huh.
applications like reporting applications, those things are transparent. They don't need to know that they go the egress and ingress. They are technical components that needs to be there in order to have a two-way communication between the systems. But for report application to call, say, product application, they don't need to know about this multiple hubs that will happen.
So my understanding is that gateways needed for public traffic, like
Yeah.
external to the system.
Yeah.
And if you're communicating within the system, that's when these zone envoys communicate directly with each other.
Correct.
So, so external traffic is needed for the gateway, and then
Hmm.
this can be internal traffic. Yes?
Precisely. Yes.
Okay. All right. Cool. That's great. That helps me understand a lot what's happening. Okay, so we have centralized. So we talked about connections between apps and retries. So I guess I can capture that here. So all apps communicate with each other through these proxies.
Correct.
Uh, and then this has a couple of benefits. Is this still on the board? Good.
Yeah.
So one is the retries, but the other is probably security and MTLS, is my guess. Is that correct?
Precisely. And also observability.
Oh, nice.
Retries, rate limiting, circuit breakers, all those things can be configured declaratively. So if you need to put some like a so you know that one of the service would be more flaky than another service, you need to have a more time for service to respond. You will be able to tune this individually in front of the service.
Great. Good. And so next one is exposing the app to external traffic, which we talked about with the gateway. And we kind of talked about too, how it's a new thing for me, at least, that the service mesh is also taking care of the gateway. To me, I learned that the
Yeah.
ingress or the is a totally separate project.
Yeah.
So, can you maybe talk about that and why we're wrapping it into one project here and
Why,
what
yes,
that
of
means?
course.
Yes. Uh-huh.
So, in um, in the majority of actually it was there even with like Istio system also for a while. It has this like a built-in I forgot the name. I forgot the name they were using, but essentially ability to expose the service to outside world
Mm-hmm.
was one of the things that service meshes were able to do for a very long time. However,
Mm-hmm.
usually when we're talking infrastructure people, they tend to use whatever the tooling was there before, even before Kubernetes, maybe before all these things. And people would use things like the Kong, APG, Nginx, just or even Apache for that matter, as a kind of like the way to put the load balancer in front of their application. Um, so in Kuma, we have a support for two things of two gateways, or two types of gateways. One is built in. There are situations where you don't really care about all this API management stuff. You just want to put the load balancer in front of your applications and flow traffic
Mm-hmm.
to your system. Technically, the way how it works in the Kubernetes, we know that there's a type of service called load balancer that
Mm-hmm.
allows you to get external IP address. So this external IP address will be acquired. You will be able to give this the DNS name for this service, and the people will able to access to your application. There's nothing fancy here, so you can also
Mm-hmm.
scale this. You can run multiple instances, so you can have real load balancing functionality. But since it is built-in gateway part of mesh, you will have all the benefits of the mesh, automatically collecting metrics, automatically enable MTLS. Since it's joined there, it's part of MTLS. It's already secured inside the gateway, inside the service mesh. Another type of gateway, it's called delegated.
Mm-hmm.
Sometimes you, before you join the service mesh, sometimes you already have a solution to to um, to get your
Get
application
traffic.
outside world. Yeah,
Mm-hmm.
you have a traffic, you have what's the thing that you were talking about? See, co.
Contour?
A contour, yes. You have a contour, you have ambassador, you have a uh, obviously Kong.
Uh-huh.
You have a like just Nginx ingress control, just simple ingress or some more fancy thing. And Kuma allows to integrate with this so-called like a delegated. So meaning that Kuma will not deploy data plane proxy next
Uh-huh.
to this delegated proxy, but also will be able to pass the traffic from gateway into service mesh.
Okay.
So many people
That makes
don't
sense.
really care about the more complex solutions, so that's why we come up with this. Okay, so just give them gateway. Just give them gateway
Yeah.
that allows them to stay consistent in their configuration, um,
Mm-hmm.
and they will be able to send the outside traffic um, to their applications.
So I would, is that, so basically, if you are building a system from the ground up or you don't already have an Ingress implementation, in general, Kuma specifically, and maybe in general, Kuma's service mesh has evolved so much that it's able to do those things. Like
Yeah,
like a Contour and Emissary Ingress both use Envoy proxy sidecars, and so is Kuma using Envoy proxy sidecars. So why not have one technology be able to do the configuration for all the types of things?
correct.
But
Um,
but the difference is that Kuma is going to have a very simple implementation because it's just younger
yeah,
in terms of doing it. Where something like Contour or Emissary, where that's their full gig, is going to
yeah.
have be more fully featured.
So, and remember, like hour ago, I asked there was some question about auth, and how you can would provide these integrations. So
Mm-hmm.
usually it's a good practice to auth. It's the way how you authenticate and work with the external users of your system. So you usually put this on the gateway side of things. So
Mm-hmm.
whenever a user comes in, this is where you need to check if they have a right credentials, they have a right access things. You checking this on the gateway side of things. You can pass through some of the information, some special header that will include what if the user authenticated or not. But usually it is the gateway is dealing with this. If I will bring back to my metaphors, gateway is the bouncer, but
Uh-huh.
service mesh service mesh in this case, it would be server that would be, routing you to the party where you will be going and meeting with other people. So you came into bar, everyone checks your this, and after that you will have a hostess or server will lead you to the party. If you want to
Uh-huh.
say, hey, I want to talk to John Doe, and
Uh-huh.
this person will take you there. So you will have, it will be responsible for, the your mingling. It's like a host in your party.
Uh-huh.
Whenever you don't know where I find John, you talk into
Uh-huh.
host, and this is you're
Okay.
doing the service
So-
discovery.
Uh-huh.
And
Nice.
whenever you kind of like it feels like someone is, the pouring you too much alcohol, and the host can
Uh-huh.
intervene saying, hey, no, that I think that's enough, and this is where we have a traffic control and the rate limiting and all these kind of things. And also host can look after you, and like watching how many the glasses of drink you already finished. That's your observability bit. You're collecting the metrics of the things. Also, host will be responsible seeing like how many people you interacted with. That's the tracing bit that also plays out here.
That's fun. Okay, I want to get through this list, but also we have a question from Kormaju. How does a pod, let's see, how does a pod place in Kubernetes using Kubernetes control plane or Kuma control plane? So can you explain how a pod placed in Kuma service mesh environment? So when
Uh,
a pod is created, let me answer and then you can tell me if I'm right. So when a pod is created, which is something done like on the worker node directed by the kubelet, that's when it's going to inject a sidecar, a Kuma pod to that, well, technically an Envoy proxy pod that is running alongside the application. So, and it knows to do that because that's configured on the Kubernetes control plane to happen. But, and that's something you do as part of installing Kuma and then setting up uh, part of the admission controller process in terms of, is that, I'm kind of flubbing it up, but
no, no, it
yeah.
is. You get the gist right. So you as a developer, when you run your application inside Kubernetes, you can subscribe to different type of events that happened. So Kubernetes provides you the way how you can do this. And one of the things that it allows you to do is to set and getting events on the namespace. How you would do this? You just get the list of namespaces, validate list of labels on this namespace. If this list of this label has Kuma IO slash something, I forgot the name, a sidecar injection. So Kuma sits and listen all events that happen in this namespace. Whenever there would be event that will be creating a pod, Kuma uh, being as a kind of like a controller that runs inside the Kubernetes cluster will intersect this process, and during the process of creation it also will inject some additional metadata. This step is also absolutely optional, because when you're creating your deployment in your container spec, you actually can put multiple containers. You can put this manually and explicitly for every container. But
Mm-hmm.
usually people don't do this because it will require extra lines of YAML. But
Mm-hmm.
also, whenever you're running this with control plane and data plane and it takes care of automation, it definitely helps when you need to do upgrade. So you're upgrading
Mm-hmm.
control plane checking that you have all data planes.
Mm-hmm.
You can bounce the pod. When you redeploy the
Mm-hmm.
pod, it will update sidecar.
Yeah. Or
All these
even if you
things,
want to change some configuration, like, oh, you know what, I want to set our rate limiting differently. I just change it one place in the Kuma control plane, and then it's going to automatically inject my changes into the stuff, right?
yes, yeah, yeah.
Yeah.
But those are kind of like if you want to change the rules for rate limiting, it is kind of like a next step. It's your
Okay.
pod already managed by um by control plane. I think what
Okay.
is
Okay. That makes sense.
Kamaraju
I
is
see.
asking is the deployment step, like who's responsible for deploying the pods. So you deploying
Mm-hmm.
the pods as usual. It's business as
Mm-hmm.
usual in Kubernetes. You deploy your pod. You have a deployment. You have your service. Or you have whatever you have when you need to deploy this. And only thing that you need to keep in mind, if you enable automatic sidecar injection, or you do this, manually. So again, manually, what you can do deployment patch. You can, you deploy deployment. After that, you can provide the patch and put the site. There's multiple ways how you can do this, but this is a not beyond the discussion. It's something like it's irrelevant.
And
How you
as
deploy
a
your applications,
uh
it's up to you.
and as a developer who's consuming it, it's something that you don't need to concern yourself with. It just
Uh, pretty,
automatically
pretty,
happens, correct?
pretty much, yes.
Yeah.
Yeah. It feels like magic, but essentially, it's just a lot of automating. Lots of steps are just automated for you. If you don't want to do this, everything can be done manually, and it's just like just any deployment that you can do with Kubernetes. Any
Excellent.
SRE of who have a, I don't know, like experience deploying any apps, uh, will tell you, whatever you need to do as a developer. So also it can be put through the pipeline with the Argo, with the CI/CD pipelines, with Argo, with Flux, or whatever you have, like whatever tools, Helm, whatever. Um,
Cool. Um, so next up we have connection pooling on our, how does connection pooling happen in our
Yeah.
diagram?
So the things with the maybe it is not like 100% to connection pooling that we did in the past, but essentially the communication between the system will still handle everything that you need to do with this. You can do some of the the caching, different retries. One of the big thing that was what we're doing on the connection pools during the database times is just having retries or automatically reconnecting things. It's already handled. We already talked about this in um
Cool. By the state,
but yeah,
by the
exactly,
applications all talking with each other.
exactly, yes.
Uh-huh. Cool. And then secure observability, I guess we talked about too. So it's all of that's happening in this
Yeah,
layer.
yeah.
Cool. And then in terms of relating other things we talked about to this diagram, I think maybe talking about what things are and where they sit. So this can be, these apps can be different pods in a Kubernetes cluster, or they could be different VMs, or they can be whole different physical machines. It regardless, it all works the same. Is that correct?
Yes, it does.
It
It,
seems
it is correct, yes.
with this conversation, I'm gathering it's a bit more difficult to install if it's a VM or a physical machine than it is if it's Kubernetes. There's some things that can be automated if it's Kubernetes that can't be automated if it's another type of system. Is that correct?
Correct. So I did a stream. I did a stream with my colleague, Mike Beaumont. He's one of the engineers on the Kuma, and he's one of the people who's actively involved in the Gateway API. And we actually showed how we started two zones. One zone was just on VMs. So we just used like EC2 instance and Kubernetes instance, and we showed that some of the stuff that we can do for you out of the box on Kubernetes that needs to be manually done. So we need to register one of the zones inside our Kuma. We get a token. This token will be signed every request that the control plane and data plane will be doing. After that, kind of like we establish this connection, we join this application into this mesh, and after that, we show how to use in gateway. We gradually we deployed second version of this application, but this time we deployed this inside Kubernetes, and using
Uh-huh.
gateway functionality, we gradually
Oh,
changed the request rate that goes into VMs, and over the time we
cool.
reduce number of requests that goes into VM by zero, and all requests will go into um, uh, into Kubernetes. With like 100%. So this is not only for application deployment, but also for application migration. For I don't know the people that might cringe about this, like cloud modernization, or the cloud migration. That's
Yeah,
one
yeah.
of the
No,
things
it's real.
once you
Yeah.
yeah, exactly, you started this in your data centers. You want to go in the cloud, you want to go with the managed services. You can gradually migrate your workloads, and with the tools that already described here, like on the gateway side of things, you can assign different weights to different version of the application.
Mm-hmm.
So when the user will comes in, um, user will send to application, and they don't know which version they're running. If
Mm-hmm.
it's and you can gradually use this approach to do cloud migration.
Mm-hmm. Uh, I'm gonna write cloud modernization. System. I can help with what? With
If
modernizing an app to cloud.
Mother
How about that?
exactly application modernization, migration to the cloud, or
Uh,
cross cloud. I think we were talking about VMs, we were talking about uh, um, um, bare metal, but
mm-hmm.
more often we have a use case where we have a multi-cloud deployment. Some people want to
Mm-hmm.
have a um, Amazon cluster and Google Cloud cluster and Azure cluster. So with Service Mesh, you will be able to have unified communication regardless of your cloud of choosing.
Cool. So because Kuma is universal, it can help with application modernization and migration to cloud or multi-cloud. And so one thing I wrote while you were talking, but I'll also say verbally, is when we say it can be run on Kubernetes or VMs or bare metal, it can also be run in any combination of those things, which is pretty powerful.
And
That's
even
cool.
Windows.
And even Windows.
We do have a use case. We do have versions of the. It's kind of like a more on the enterprise version side of things. So we have a Kong mesh that we built on top of Kuma, and we do have one or two customers who wants to run their workloads on Windows, and they need to have a data plane proxies deployed to next to their web applications, or like the Windows applications. Um,
Cool.
yeah.
And then the other thing I want to mention here is geographically. So are zones always going to be in different geographical regions? Like, is that the point of zones?
Not necessarily,
Okay.
but that's the biggest use case how the people use. I did um, not the last year, so like maybe 2 years ago on the Kong Summit, I also did the demo multi-zone deployment of the Kuma, where I showed the example how uh, location aware load balancing can be taken into consideration. It's a
Mm.
big use case for organizations who wants to run geo, like they have a
Geo
specific
replication. Mm-hmm.
geographical requirements to do this. So
Mm-hmm.
that's why we usually um, kind of have a common term. Okay, so we're doing this like geographically distributed, but um, whatever they want to use to segregate or like change where the things will be deployed and things like that.
Cool. So I think that's all we need to do to relate everything that we talked about to our diagram. Is there anything else you feel like we should mention as far as that goes?
So one of the things in terms of developer experience, we right now in the process of rewriting some of the rules for better simplicity. We always look into ways how we can improve and simplify user experience. So right now, if someone will go to Kuma documentation right now, kuma.io, and you will find there would be something like a, say, policy called rate limiting policy and called mesh rate limit policy. So the mesh prefix, that would be new policies, and we recommend everyone, if you're starting over, just use them, even though they say they in beta, but we recommend people to start this. If you go in from the previous versions of the Kuma and you're trying to go to new versions, stick to the old versions, or like over the time try to migrate. You cannot have both versions because they might conflict, and the rule engine might go crazy about what kind of like services needs to be matched there. But we believe that starting with the Kuma 2.0, we believe that this those policies that we introduced, and they would be better for much more clearer and cleaner the definition how those rules would be applied.
Cool.
um and there's some advanced features that potentially can be implemented, things say WASM, like WebAssembly is
Mhm.
a big thing, and Envoy
Yep.
has engine that allows you to execute the WebAssembly filters. Um, in order to configure this, there's no policy, but
Mhm.
Kuma provides the generic way, we call it proxy template, that with the proxy template, we can inject actual snippets of Envoy configuration. That's kind of like a more advanced use case. Remember when I was talking
Okay.
about this brain to arm connection?
Uh-huh.
Brain will interpret it kind of like a human readable or human understandable words, and after that
Uh-huh.
will translate to the signals that will understand this. So
Yeah.
Kuma does this by providing you syntax of the policies, because
Uh-huh.
everything will be translated down to Envoy configurations.
Yeah.
With the
And
proxy template, you have
mhm.
ability, kind of like a neural link. You can just inject yourself and start programming your hand directly without brain. Same thing with the proxy template. You will have ability to program directly into maybe have some advanced filtering configured. You want to have some Envoy filters, the WebAssembly filters enabled on every data plane proxy. How you can do this? This is how you can do this. You need to provide the proxy template. We didn't talk much. Again, it's a more advanced routing. It's called we have virtual outbound. It's kind of ability to have some sort of like a NAT-like system inside the service mesh. Um, I did the example. I did the I guess last year at the Service Mesh Con, I showed how we can use the virtual outbound inside the service mesh in order to represent or like hide some of the Kafka details. For example,
Mhm.
Kafka, again, you see, full circle. You know, I'm
Yeah.
bringing everything the together. Um, Essentially, Kafka, in order to application client connect to Kafka, each node of the Kafka cluster needs to be available, because Kafka doesn't do any kind of like a load server side load balancing. It's called like a client side load balancing using consistent hashing. So
Mhm.
every node needs to be exposed. But this is also difficult in the world of ever changing the node's addresses and things like that.
Mhm.
By
Yeah.
providing like a virtual outbound, we can have a consistent naming that will be backed by Jesus. What was the uh, there's a demon says what's the another one? Replic said no. Uh,
Stateful set?
Stateful set, exactly. Yes, thank you so
Uh-huh.
much.
You're welcome.
Backed by stateful set, we will be using stateful set to deploy nodes, and after that, we'll use virtual outbound to have a very nice looking URLs. For example, Kafka 1, Kafka 2, Kafka 3 dot
Oh,
mesh,
nice.
these type of things.
Cool.
So
Cool, cool, cool.
there are a lot of like some of the advanced things on the routing that we will try to support. But I think this is the this is the question for a different for the different stream. Maybe write down,
Yeah.
like, if this video will get I don't know, 5,000 views and we have 1,000 likes. I will come back and we'll talk about
I'll do
Kafka
it.
on Kubernetes and the
Uh,
Kafka on Service Mesh. How about that?
yeah. Is it like a Kuma 201 or is it
Yeah,
yeah.
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 It's more like a 301 because yeah, 301. It will be more advanced.
Cool. So to wrap up, if anyone has any questions, please do ask them now. To wrap up, what I'm going to do is take a few minutes and go recap everything we talked about to make sure I have a good understanding, and therefore everyone who's watching also has a good understanding. And we can go from 0 to 100 on Kuma in 2 hours. We got this. And then to close it out, I'm going to replay the intro music and we're going to dance a little bit and then say goodbye. So that's what's happening. All
Okay.
right. So we started the by saying, what's the service mesh? It's a technology that gives you a centralized control plane over application communication, which is, I love that definition because a lot of, before I started this series on service mesh, I 100% had the idea that service mesh has to be a Kubernetes sidecar, and it does not. So the goal is not to have to hard code some of this stuff into the application, stuff like service discoverability, connections between apps, including retries, centralized configuration, exposing the app to external traffic, connection pooling, security, observability. These are all things that can be done in a service mesh, and then our application developer doesn't need to worry about hard coding it into their application at all, which is apparently how it used to be done. Someone, we have a couple of thank yous. Kumarju says thank you. Thanks for answering all my questions with analogies. And then we also have a nice thank from Epic Tralala, who says it's time to test Kuma, which is great. Yes, let's play. That's
Yes.
the next step.
Let's go.
So then we needed to give some context to this whole scene. So we talked about things like Envoy. Envoy is a super fast proxy, and it's used in many technologies. So I just wrote the ones we've touched on Enlightning. So it's used besides in Kuma, it's used in Istio, Contour, Emissary, Ingress, etc. But what I understand about Envoy is that it's very, very, very complex, and it's not really meant to be interfaced with by humans directly. You need another technology to make it just like you
It is.
can't understand how your brain is making your hands move, like that's too far
It
advanced, but
is.
we just know it happens.
They even have their own the protocol. It's called I think XDS. It's the protocol that they use. It's gRPC based, but this
Uh-huh.
protocol used to communicate between proxies, between the control plane and proxy. So it is whole another level
A whole of
and I'm not
complexity.
trying to pretend that I know everything about this because the
Uh-huh.
protocol is very complex, configuration is very complex, but also very flexible.
Cool. So Linkerd is different from Kuma in that it doesn't use Envoy. It uses its own. It uses its own. I said Envoy, but I meant proc. Oh, it doesn't use Envoy. It uses its own proxy that it wrote, and to just do the bare minimum that service mesh needs to do, and trying to make it lighter weight. And then Istio uses Envoy, but has a hard dependency on Kubernetes. So Kuma is a universal control plane for your service mesh that uses Envoy, but it is not Kubernetes specific. It can run Kubernetes VMs or bare metal. And then just for more context, a control plane is the brain. You set the config in the control plane, and then the control plane in turn configures the data plane. And the data plane is responsible for actually doing the thing. So Kuma has, when it was created, these technologies already existed, but it had three goals to make a new service mesh that is needed in the space. One is we want a super duper simple developer experience. Second is that word universal, the universal mesh, where it can be run on Kubernetes, but it could also be run on VMs or on physical machines or on any combination thereof, which is important that we'll get to later. And the third thing is we want that for it to be able to be geographically distributed And we want that to come out of the box. We want it to be easy to do geographical distributed systems. So some of the benefits of Kuma, we have universal discoverability. And that way I would say is part of a simple developer experience. So it's easy to find the different services that are running in your system. We have declarative traffic policies. So one example we gave of that is like if only a gateway service is allowed to call the products service. Only
Directly,
the
right?
gateway is allowed to directly call products or any such thing. Only, yeah. So you can make your traffic policies declarative. There's security, so we're automating the act of secure connection. So without any thought, there's going to be MTLS communicating between our systems. And then we also talked about for the certificate rotation is automated too. And then we have observability as one of our benefits. So metrics, traces, logs. We have apparently there's a very nice UI that we would, so in this system, we'd check out the UI of our global control plane to see everything that's going on. And
Yeah.
then there are a lot of things are automated for us and come
Yes,
out of
by
the
the way, if
box.
you want to see all this UI, just go check out our stream that we did with Whitney at the CNCF YouTube
Oh,
channel. Yeah,
yeah.
you'll see UI, and like one last thing in on the global side of things, we actually, before I was on the stream, we didn't have this, but we just announced that we have now managed global control plane um, as a part of our kind of like a Con Connect platform. So we use this technology um, internally, and we also provide a kind of like a experience if you don't want to, or like there is no need for you to host a global control plane. We can host it for you, and you can plug a the different cloud providers with this global control plane, so you will be
Cool.
able to have a one view to all your deployments. Actually, I think it will make a great demo. I need to do this. I need to do this for KubeCon.
Cool, cool. Yeah, totally. So these benefits, pretty much all of them can be realized without the developer having to change their application code. The only thing is traces was the only exception. So in addition to all this rad service mesh stuff, Kuma can also be a simple ingress too. So if you don't already have an ingress implementation, it can help you do that. But if you already do have an ingress implementation, it can plug into your current ingress pretty easily. So you can run Kuma either as a sidecar in Kubernetes, so in the same pod as your running application, or you can run it as an operating system process, which is a more involved installation. So if you do it as a sidecar, it's good because it's easier, and it's good because Envoy shares the network with the application container, which helps with all the automation and just simplicity in terms of setting it up. So then we took some time at like it's like a win, lose, or draw, or like a Pictionary situation where you describe to me what to draw and I'm drawing a system. But I like that because I
But
really
you
like
did a great job, and
thinking out.
you
Thank you.
you even left a little bit on the screen, so you will be able to, we will be able to
To
see you.
see.
Yes.
Yeah, that's a problem I need to solve every time. So,
Yes.
but I like the act of talking through it because we're talking about why we're choosing what to put where. I think that's valuable discussion. So, so in this system, a product request would come in through the gateway, and then the gateway itself is part of the Kuma service mesh. And then the gateway would makes the request for products, for example, and then it would receive the response. And so the gateway can inject tracing headers there. And also you can, this is be a good place if you wanted to set that policy that we talked about, the declarative traffic policy, you could do that here. And then as a human, everything that's moving around the system, I can observe all of that in the global control plane in a nice UI. And then if you're using Kubernetes, part of what makes the Kubernetes implementation nice is that you can add different zones or you can add different applications, and it's a pretty simple process. Like it's the stuff's already injected and everything is discoverable. And then also like related to Kubernetes, because these can be VMs, they can be physical machines. If you're an organization that's looking to modernize, that's looking to upgrade your stuff from VMs to Kubernetes, you can implement Kuma on both, and then you can even use Kuma to like slowly move your traffic from one system to another. So it seems like it could be a really helpful part in terms of your modernization journey as
Yep,
the
exactly. Yeah.
yeah. And I think that's it. The geo what did
Yeah, I think
where
you
did
did
I
a
write
great
down?
job explaining everything and summarizing everything. It was a lot.
Yeah, we got it. Okay, yeah, great. Thank you. I'm happy you're happy. Is there anything you would like to add to the board? I'll find a way to fit it on.
No, I
Do you feel like we
think
got everything?
put this kuma.io. This is the place where you can start with this. You
Yeah,
can
I'll write that
learn
down.
where you can deploy this, how you can deploy. If you think there's something that can be improved, it is open source. That we have a Slack where you can seek for help and find bunch of training resources. Just Google the Kuma service mesh at the YouTube. You probably find some of the videos me or my colleagues were doing about
Right
this.
in. Awesome. Cool. Let's dance our goodbyes. Thanks everyone for coming today. Thank you, Victor, for sharing your time and attention with us. I appreciate you. Oh, yeah, here we go. We're gonna dance until the bass comes in. Yeah, I like it. I'll do yours. I have, you can't see my body, so I do a lot with my hands to try to convey that I'm dancing.
Here we go.
Bye.
The bass comes in. Bye
Yeah,
bye. Thank
goodbye,
you.
goodbye.